Hello everyone, welcome back again. But with a new topic. Read out the heading, rationalizing the denominator. Yes, have you seen these type of expressions? Yes, under root 5, under root x. Basically, the root ones are sitting here in the denominator. It's very frustrating to solve them. Yes, sometimes whenever you are sharing a cake, whenever you are sharing your Netflix password, you want it right, you want it in a clean manner. So in mathematics too, we need these terms to be in a clean manner to get it solved further. While these root ones and sitting in the denominators are not easily calculated. So we need to remove them, we need to root free them. So that process is known as rationalization. Yes. So should we explore it together? With an excitement, a smile on your face. Yes. Like this boy, he's thinking something. You must be thinking, how are we going to do that? Yes. So what's more powerful? What do you feel? Leaving things messy or cleaning them up? Obviously, we need to clean the things up in order to feel good, in order to solve better the terms in mathematics. Yes, that's why there is the need of rationalization. That's why we care about rationalization, but rationalizing the denominator. If the rationalization we do in the numerator, there is no point. Let's suppose the under root is present in the denominator. It would further lead to give you a clean number that will help us to calculate easily in order to get fraction addition easily. Let's suppose here I have just made it a clean number 5. Now you can just add it easily. Fraction addition is easily done. Now what if the number is, the root is present in the numerator? It's not that much tough to add them. We can easily add them. We can take the LCM, we can further add them. Although the result is giving you the irrational terms, but it is not that frustrating like the root ones present in the denominator. So we need to calculate until we can. We can simplify until we can. Yes, so that is why there is the need of rationalizing the denominators in order to get fractions more clean manner. So we will understand what it means to rationalize the denominator, what it means, how to remove irrational numbers from the denominator. Yes, we will just understand a foolproof method. The process of removing irrational numbers, root ones like under root 2, under root 3, etc. from the denominator of a fraction, that is what the definition of a rationalization. Yes? Would you remember it for life? Just making the denominators root free. We are going to make the fractions in a cleaned manner. Yes? To express values in standard form and ease of calculation. Yes, when it would be in standard form, it would make them to solve easier. So let's just do this process. When denominator contains, when is the need for rationalization come alive? When the denominator contains the root ones, it could be in the form of single root under root a. Let's suppose 1 by under root 5 is present. Yes. Or it could be a plus minus under root b. That means what? It could be, let's suppose a is 3. If you take plus under root 2, this could be one fraction, one expression, and it could be 3 minus under root 2. The same thing. That is the need of plus minus, means either you can take plus between these two terms, either you can take minus between these two terms. Yes. So whenever these type of expressions are present in the denominator, maybe single root is present, maybe in the combined form, the root is present, we just need to make these messy looking numbers into root free clean manner. And we have understood how to simplify the numbers in the previous session by solving most of the examples. Now you can just easily be getting this process. So here the denominator is a form 1 by under root a, 1 by a plus under root b that I have just shown you the example of. We use the conjugate as it flips the sign. So this is the first step. How are we going to apply this rationalization? See, if the number is present single, then there is the no use of sign. Yes, but when the number is present in the combination form, like there are two terms being operated, being plused, being subtracted. Here, let's suppose a plus under root b is there. What would be its conjugate? The same terms but with the opposite sign. Here the terms are getting summed up. Here the terms are getting plused. But here the conjugate is getting subtracted. The term is same, A is same over here, B is same over here, but the sign is not same. That is its conjugate form. The opposite of sign. Plus would be changed to minus, minus would be changed to plus. That is the use of conjugate. Only when the two terms are present, then we would use this concept of conjugate. Either way, if the root is present single, then we can simply do that. You don't worry, I'm just telling you the examples. We'll solve in detail step by step with a long proof method. Okay, so firstly solve this 1 by under root 7. Just note it down, 1 by under root 7. It is looking messy, isn't it? 1 by under root 7. Have you written? 1 by under root 7. Is conjugate needed over here? I have just told you only a single term is present in the denominator, root 1, but here we don't need conjugate. Conjugate itself is what? Just taking the opposite sign of the two terms, but here we are not even having two terms. So there is no need of having conjugate. You can simply multiply and divide with the same number present in the denominator. The second step is whatever the denominator is, the same number is going to get multiplied, is going to get divided. Basically, what are we doing? Under root 7 got under root 7 get cancelled and giving you 1. So basically, we are not changing anything. We are just changing mathematically its form. Here, the thing is 1 by under root 7. When it will be cancelled, it is giving you 1 only. So we are not changing anything. The form is same, but the mathematical expression is different. So the same number is getting multiplied, and there is a rule in mathematics. Whenever you are multiplying something with, you need to divide with the same term also. So that multiplication and division getting cancelled with each other. So here, multiply the tops now, under root 7. And here, multiply the bottoms, under root 7 multiplied by under root 7. That means what? Under root 7 is same. Here, I can take the under root in the combined form, and you can write over here, and 7 into 7 is 49. And you know that 49 is a perfect square of 7. Have I removed the under root in the denominator? Yes, you can see. Although I have not removed the denominator, removed the under root from the term itself, the under root is present in the numerator over here. But the main point of rationalizing the denominator was to make the denominator free of roots. Is it? Initially, the root was present in the denominator, but the answer does not contain the root in the denominator. We don't care if the root is present in the numerator. It doesn't make our calculation harder. Let's just write it in a right manner. Just note it down. That was this step. Multiply numerator and denominator by the same term, that was under root 7. Yes. And you know that under root 7 multiplied by 1 under root 7, and basically it is getting your under root 49, and under root 49 is your 7. Let me just write the step. You can write in detail also. Ultimately, that is the answer. Not it? Was it easy? Can you do that? It's very easy to perform with the single term. Now here is the time to apply the process with the two terms. Yes? What is the first step? I have discussed with you. Conjugate. Just multiply and divide it with the conjugate of it. What is the conjugate? Just write along with me. The fraction is this. We need to rationalize. What's it conjugate? Just take the opposite of sign along with the same terms. Yes? Now get it multiplied and divided. How? 1 by under root 5 plus under root 2 getting multiplied by under root 5 minus under root 2 divided by under root 5 minus under root 2. We need to solve it further. Multiply the tops, multiply the bottoms. You just note it down till here, then we will move further. We need to multiply the tops, we need to multiply the bottoms. Multiplying the top is very easy. The number will be keeping as same because it is getting multiplied by 1. But in the denominator, what it would be? Do you remember the identity? A plus B and A minus B will be giving you identity is A plus B, A minus B is equal to A square minus B square. This is your identity. Just apply this identity over here. It is also A plus B. Here also A minus B. Means the terms are getting summed up initially. The terms are getting subtracted initially. And they are present in multiplication form. These are getting multiplied. So that would be applicable. A square minus B square. A is what? Your first term. Take square of it and take square of the second term. This square would be cancelled by this square root. This square would be cancelled by this square root. So in the denominator, what would be present again? 5 minus 2 only, that is your 3, and keep the numerator as it is. That is your answer, under root 5 minus under root 2 divided by 3. That is your answer that I have shown you how to represent it. Now I'm just erasing it. Just want you to show the exact method, exact answer. Just note it down. You just have taken the conjugate over here, multiply and divide the denominator by under root 5 minus under root 2 over here. Yes? And you can see. Taking the conjugate, applying the identity, you just write here using the identity. Using the identity, that is A plus B, A minus B, giving you A square minus B square, that is under root 5 plus under root 2, under root 5 minus under root 2, giving you under root 5's square, under root 2 square, giving you 3 ultimately. So your denominator has turned root free. That was the process of rationalization. Just note it down. Once you get the process, I'm just taking time here while solving these two basic questions only, because you will be getting pro. You will be getting perfect by each next example. You will be doing it by yourself with much more ease. Just note it down. We'll move further. Easy? What was the new thing over here? Conjugate we have applied and identity we have applied. Now do that by your own. 5 divided by 3 plus under root 2. Same thing. Multiply and divided it by its conjugate. What is the conjugate over here? Just change the sign. 3 minus under root 2. Step 1. 3 minus under root 2. Just do it like that. 5 by 3 plus under root 2. That was your previous fraction. Now we are getting multiplied and divided it by its conjugate over here. In the next step, multiply the tops and multiply the bottoms. You will be getting your answer. 5 threes are 15. We are using distributive property. 5 threes are 15. 5 under root 2. Yes, these are not like terms, so they are just getting stuck with each other. 5 under root 2. Here, this identity is again used. A plus B, A minus B. In most of the cases, the identity is used over and over again. You just remember it for life. A square minus B square. Your A would be changing every time. Your B would be changing every time. But your method would not change ever. 9 minus 2. That is your 7. What would be the next step? You don't have to change the numerator. Keep it as it is because we are not bothered about numerator. We just need to make the denominator root free. That was your answer of this question. Just note it down. I hope now you are finding it easy to just rationalize the denominators. If you still have some doubt, you can just ask your teacher. I just want you to solve one more question. Just note it down, we'll move further. The topic is not tough. Don't be scared. The topic is not tough. It just needs more practice. After the class, when you just get home, just try to spend half an hour on this topic. You will be getting perfect. We'll be revising the things. You don't worry about that. So your answer is right here. Now just do it following the same steps. 2 divided by under root 3 minus under root 5. First focus is just finding the conjugate. Just opposite of the sign. In the fraction, that negative sign is there. In the conjugate, there would be positive sign. It's just opposite. It's not necessarily means that always we are having the positive sign in the fraction and the conjugate will be having negative sign. No, it doesn't work that way. Whatever the sign you are taking, take the opposite of that. If you are taking plus, you have to take the minus. If you are taking minus, then you have to take the plus in the conjugate. Now just apply the same thing over here. Just get it multiplied and divided by the conjugate. This is the actual fraction, 2 by under root 3 minus 5. Now here is the conjugate, here is the conjugate. The thing is, that is your actual fraction. We are doing like that. Yes? Your next step will be containing the identity over here. A plus B, A minus B. Again, A square minus B square. Your A is what? Your A is under root 3. You need to take square of it. A square under root 3 square. Square root got cancelled by square. Your answer is 3. And again minus B square. Again minus under root 5 got squared. Square root got cancelled. You are getting minus 5. That means 3 minus 5 you are having over here. But in the numerator, you are getting like that. Just put the bracket. A square minus B square. 2 would be multiplied by root 3. 2 would be multiplied by root 5. Here 3 minus 5 is giving you, that is minus 2 under root 3 plus 2 under root 5. But you know that we don't leave this minus under the numerator. put this minus under the numerator, it would change their signs. So both of the terms will be in negative, under root 3 minus 2 root 5. Yes, I have taken this 2 common over here. This is not tough. Just take 2 common out of that. Now bring this negative upwards. That is your answer. Just note it down. First thing is again taking the conjugate, getting it multiplied and divided. Then you would be getting in the numerator, basically we are applying the distributive property. 2 would be multiplied by 3, 2 would be multiplied by 5, yes. And in the denominator, always we are applying a plus b, a minus b identity. That is your a square minus b square. Yes, when the two terms are summed up, when the two terms are getting subtracted, the same two terms. Yes, the same two terms. That is the basic foundation for this identity to be applied for. The two terms are same. 3 minus 5, 3 plus 5. But only with the opposite of sign. Then only the identity is applied. A square minus b square. A is your first term, take square of it. B is your second term, take square of it and just minus them. You would be getting your answer just like that. Yes, now let's do an activity. I hope you have understood the rationalizing process. It will be prominent by doing this activity. You have two expressions. A is 5 by under root 2 and second is 5 by 2 plus under root 2. Just write them in the standard form. A is 5 by under root 2. B is 5 by 2 plus under root 2. Yes? What is the question? Have you noted these two expressions? Which one do you think will be easier to rationalize? Which one would be easier to rationalize? The conjugate one. Conjugate one is a bit difficult than the simple one. Obviously, the single term is quite easy to be solved. Why? You just need to take same number, get it multiplied and divided. 5 by under root 2 getting multiplied and divided by under root 2 itself. And in the second thing, you need to take the conjugate 2 minus under root 2. So that makes it a bit tricky. So which one is easier? First one. Priya says that rationalizing 1 by under root 11 and under root 11 by 11 are same. Just read this question carefully and just answer me. I want you to answer it. Just solve. I'm giving you 1 minute for it. Just solve it. Priya is claiming both numbers are same. How these numbers are same? This number and this number are same or not? They are not looking same, but we need to find out. Just solve it with me. Solve it. First step will be what? Let's solve it firstly. How are you going to solve it? Taking the same number, getting it multiplied and divided, yes. Same thing, we don't need conjugate over here. Then multiply the tops under root 11, multiply the bottoms. What are we doing here? Just multiply them. Eleven multiplied by 11 is what? 121. And you know that 121 is a perfect square. Just write it over here. Under root 11 by 11. As you know that under root 121 is your 11. Isn't the same number? Isn't it the same number? 11 by 11. So Priya was right. Yes, interesting. We thought it is not same, but once we solved it, we find it same. So that is what the magic of maths. Yes, without pen and paper, you cannot say anything. Once you find a question more easy, try to do it. Maybe you can be stuck somewhere. And whenever you are just looking at a number or a question, you find it, no, it's very tough. I cannot solve it. Try using pen and paper. Maybe you just find a trick. Maybe you just got your subconscious mind active and you would be getting the answer. So practice is must. Just note it down. Both are equal. Priya is correct. They are just two forms of the same value. We have solved it. Noted. Same number was there. We don't need any conjugate. We just get it multiplied and divided. We got our answer. You are given the expression. Without simplifying it, do you need to rationalize the denominator? Without just simplifying, can you tell me what would be the answer? Do we need the process of rationalization over here because the denominator is containing the root 1? Do we need to rationalize it? Do we need to get it multiplied by divided by under root 3? What do you think about that? Just think deeper. I'm not going to answer it. Just think deeper. You have to answer it. It's very easy. Just read the statement again. You will be getting it. My question is, here the rationalization is needed or not? Here the rationalization is needed or not? Nowhere needed. It is getting cancelled. Under root 3 by under root 3 giving you 1. Magical? So yes, you don't need anything. No rationalization needed. Already rational. Why we need to make the denominator root free, although we have just made the number root free. Yes, so that was our session for today, rationalization. I just want you to practice it. It's must for practice. Otherwise, you won't be not getting so sure. Please practice it. At least try 2 questions from your textbook of an NCRT 1.4 question, 1.4 exercise. Try to do any 2 questions of rationalization based. And please take the help of your teacher.